Alright, welcome back everybody. This is our second video for the lesson on dividing complex numbers. And our focus here is going to be on raising I to higher powers other than the first. We've already looked at the second, but we're going to look at what happens when we raise it to even higher powers than that. So we'll go ahead and start with that. We know that I is equal to the square root of -1, which means that I squared is equal to the square root of -1. Well, let me go back a little bit here. We've already talked about this, but my eraser doesn't want to work right now. All right, so I squared is equal to I times I, and we know that I is the square root of -1. So this is the square root of -1 times the square root of -1, which is equal to -1. So that's the value of I squared. I cubed I can break down into the product of two powers of I. I cubed is equal to I squared times I. And we just found out, well, we knew before, I squared is equal to -1. And so this is equal to -1 times I, or just -I. And so I to the third power is equal to -I. All right, how about I to the fourth? I to the fourth is equal to I squared times I squared. We know that I squared is equal to -1. So this is equal to -1 times -1. -1 times -1 is +1. We're going to continue developing higher powers of I like this. Let's go to I to the fifth. I to the fifth, we can break down using exponent rules into I to the fourth times I. We just found out that I to the fourth is equal to 1. So this is equal to 1 times I, or just I. Oh wow, I to the fifth is the same thing as I. I to the sixth. I to the sixth is I to the fourth times I squared. I to the fourth is 1. 1 times I squared. And I squared is equal to -1. So this is just equal to -1. Oh wow, I to the sixth is the same as I to the second. I to the seventh, you should be starting to see that a pattern develops here. I to the seventh is I to the fourth times I to the third. I to the fourth is 1. I to the third is -I. And so this is equal to -I. And finally, I to the eighth. That's I to the fourth times I to the fourth, which is 1 times 1, which is 1. And so you see we've got this pattern that's repeating here, where I to the first and I to the fifth are equal to one another, and I to the second and I to the sixth are equal to one another, and I to the third and I to the seventh are equal to one another, and I to the fourth and I to the eighth are equal to one another. And this pattern continues. For instance, I to the ninth is going to be equal to I to the fifth, which is equal to I. I to the 10th is going to be equal to I to the sixth. I to the 11th is going to be equal to I to the 7th. I to the 12th is going to be equal to I to the 8th. And that pattern just keeps cycling through every 4 powers of I. And that's going to help us to find the value of significantly higher powers than I. And here's the rule that we're going to go through. If we want to find the higher powers of an order, higher powers of I, we're going to take the power of I and divide it by 4. The remainder will determine the new power. For instance, if we did these, if I divided I to the fifth by 4, that has a remainder of 1 when I divide I to the fifth by 4. So anytime we have a remainder of 1, the result is going to be equal to I when we take the power of I and divide it by 4. If the remainder is 1, the result's going to be I. If I have a remainder of 2, that's going to be equal to -1. If I have a remainder of 3, that's going to be equal to -I. And if there's no remainder, that's going to be equal to +1. Something that can be very helpful for you is if we do these in a calculator, if we take a power of I and divide it by 4, if we get a decimal value of 0.25, that maps directly onto a remainder of 1. If we get a decimal value of 0.5, that maps onto, being equivalent to -1, a remainder of 2. And if we get 0.75, that maps onto 3. If we get a remainder of 0, it's just going to come out evenly when we do the division. So let's go ahead and use our calculator to help us do a couple of these. We'll see some examples here. We're going to go ahead and do I to the 105th. So all I'm going to do in order to do this is I'm going to take 105, divide it by 4. I get 26.25. 0.25 means a remainder of 1, which means that I to the 105th power is just going to be equal to I. Let's do the next one. I to the 46th. So I take the 46th power, divide by 4. I get a remainder of 0.5. That's like getting a remainder of 2 when we divide. A remainder of 2 means that it's equivalent to -1. So I to the 46th power can be replaced with -1. I to the 679, I'm going to go ahead and take 679 and divide it by 4. I get 0.75 as my decimal, so that's a remainder of 3. When I have a remainder of 3, that's equivalent to -I, and so this is equal to -I. All right, some practice problems for you. Go ahead and pause the video for a few minutes and do these practice problems, and then we'll be back with you to go over the answers to these momentarily. Okay, so go ahead and pause your video now and do these problems. All right, welcome back everybody. You see the answers to these remaining practice problems. Please check your answers. Make sure you're okay with everything that you see going on here. And then you can go ahead and start your homework. You see your homework at the bottom of the screen here. It's page 466 to 467, 57 to 83 odd, and 95 to 109 odd. So go ahead and start working on that now. And I'll see you all tomorrow. Have a great rest of your day. Bye-bye.